This is question number 5. And so reading the question, this function represents the amount of energy a battery has after t minutes of use. So I put in 8 and it's going to tell me how much energy the battery has after 8 minutes of use. Okay? So when I look at part A, state the amount of energy the battery held immediately before it was used. Well, immediately before it was used, that must mean that time equals 0. We haven't used it at all. And if time is 0, then that's going to be 0, that's going to be 0, and so our function is just left over with 25, the y-intercept if you think about it. So state the amount of energy, it is equal to Q of 0 is equal to 25. And there's part A. Part B, calculate the amount of energy available after 20 minutes. So the amount of energy after 20 minutes, and you would just be putting in 20. Because they're saying calculate, I am expecting you to show me this work, how you calculate it. Okay, there's 1 point for writing down your method there, and from there I would just go up to my calculator. You can see I've typed it into the equation, and that's one possible thing to do, or I can go and type all this in. I'm actually not going to do that for a moment, just to show you a neat little trick. Because I've typed it into the equation, I can actually go over to a table, and here are all the x values. And so if I just go down, and this may take a second, but I can find out at 20, hopefully I didn't go too far, I did. At 20, it's 13.7. So, and someone asked, do we need to put down joules or something like that? They really don't specify, so we'll leave it at just 13.7. And that's a quick way to calculate or use a table if you need to find a value and you've typed it into the equation like that. Or like I said, you just write that in, put it into a calculator, and solve it. Part C, given that Q of 10 is 19.5, find the average amount of energy produced per minute from the interval 10 to 20. And so part C, here's what we know. That at 10 minutes it had 19, and at 20 minutes it was down to 13. So you can think, if I were to make a graph of that, that it was going from 10 to 20, it went from 19 down to 13, and finding the average, well, that's pretty much finding what was the middle. So basically it's sort of like the midpoint on the x value. So we need to take our value of x, or sorry, our value of y, and for at 20 minutes, and subtract that from at 10 minutes. So 19.05 minus 13.7 over 10. And let me bring my calculator in here. Try that again. 19.05 minus the 13.7. What you're figuring out is, here's how much energy it used. 5.35, and it did that over 10 minutes. So the average amount of time it was, or energy it was using, is equal to 0.535. Whoa. Okay. And let me just make that pretty. So there's your answer to part C. And then finally part D, calculate the number of minutes it takes for the energy to reach 0. And I'm going to do that up here. Calculate for it to reach 0. So really I'm going back to my equation and setting it equal to 0. So 0 equals, because I need to find the number of minutes, which is t. Okay. A few ways to do that, but the easiest way will be to go back to our calculator. I can graph it and try and see, but what I see here, if I make the graph, that's what I get. I don't see anything. And why? Well, you have to figure that it's at least going out to 20 minutes, and my calculator stops at 10. Also, the y-intercept is the way up here at 25. My screen stops at 10. So I might change that a little bit. I don't need to know negative time really, so we'll change that. I'm going to throw this out to 50 minutes just in case, because I know there was energy at 20 and I know we started at 25, so this should give me an idea. And then we see, oh, right out at 20 or at 50, it was getting close, so let me just expand that. And why have I done that? So that I can go back and calculate when is my function equal to 0. Number 2, and here the cursor, they're asking me, I'm telling the calculator, don't look farther left than that. Go past it. Don't go any farther to the right than that. And somewhere here in the middle, you're going to find 0. 53.99, so that will round up to t equaling 54.0 minutes. And there is question number 5.